Hello and welcome back to my YouTube channel. This tutorial is going to be a part 2 to our 3 ways of how to extract coordinates from the vertices of a polygon or a multi-polygon series. In the part 1 we looked at a longer expression and how we can use that to get a very simple string that contains the coordinates of our vertices of the polygon. In this example, in this tutorial, we're going to look at a very short expression and how we can use that very short expression to also get a similar output, not the same, similar output. And you will see why I use similar instead of the same. Okay, so let's just get down to it. If you don't have your processing toolbox open, you can just on your toolbar menu, so you just click on this icon, the toolbox icon, you click on it and it will open up your processing toolbar menu, the processing toolbox menu. So if you don't have your field calculator in your recently used section, you can just, in your search bar, you can type field calculator and then you just double click on the field calculator to open your pop-up menu. So in our input layer, just like in the part 1, we are just going to go with the Ghana shapefile. If you have any other shapefile, you can use that. It's not necessary to use the same shapefile I'm using, but in order for you to be able to follow along perfectly with what I'm doing, I would make the shapefile, the Ghana shapefile, available to you down the description below. So you can go there and you'll find a link to downloading this shapefile. Okay, so in our field name, just like part 1, we're going to use the same field name, vertices coordinates. It's going to be the name of our field. The result field, also just like part 1, is going to be a string. If you are using a different QGIS version, instead of string, you might find string list. I think if you find that one, string list in the possible options, just choose that one instead of string. But if you don't have that, then you just go with just plain old string. Okay, so we're going to leave the field length empty. We're going to leave the field precision empty. So in our expression text area, we're just going to copy and paste this simple expression. You will find the expression down the description below, so you can go there and copy it so that you can work with it. And as you can see down the preview, we have our result. If you get the same thing here for Accra Metropolitans, you know that is correct. You can check that one with our previous expression and you realize that it's the same. The only difference is that attached to our coordinates we have multi-polygon, right? Multi-polygon, and this particular way of writing coordinates is what we call WKT, which stands for well-known text. Right, well-known text. It's a way of presenting coordinates. So in our previous example, it was just in a string. Then you can decide to save the resulting shapefile, but I'll just leave it. See, if you don't save it on your machine, it will create a temporary layer, meaning when you exit from your QGIS project, you lose the shapefile, but it doesn't really matter for me in particular. But if you want to save it, you can click here and then you can save the file. Okay, so we'll just run, and then we have a new shapefile has been created for us called calculators. So right now by clicking, we're going to open attribute table. We're going to open our attribute table, and then in this in the last in our last column, we have the vertices coordinates, and what we named it vertices coordinates. So the vertices coordinates for Bako, we have a myriad of coordinates for Bako, and for almost all of them. This is it, right? That is all you have to know. But I'm going to give you a small bonus. Maybe you don't want your coordinates to be in the same coordinate system as your layer. Maybe you want it to be in a different coordinate system. How do you do that? How do you do that? So I'm going to show you how to do that. It's very, very simple. It's very, very simple. So we'll again right click our field calculator. So we'll use our calculated shapefile layer, and then here we'll say change, we'll say new SRS. SRS stands for coordinate reference system. So new coordinate reference system. Yes, we'll just say new. Yes, we'll just leave it like this, and then the field type will be in string. We'll leave the length and position empty. As for our expression, we're going to have this, and then instead of just putting the geometry here, we are going to, instead of watching me type all this, I just wrote it off camera. So we have this, right? As you can see, our coordinates has been transformed from, initially it was in eastings and northings. Right now it's in latitude and longitude. That's why we have the negative 0 point something and then 5 point something, right? So we have successfully converted our CRS, our coordinate reference system, from the current one to WGS 84 universal. Okay, and then we run, right? Good. So when we look at our vertices coordinates, it's in eastings and northings. The new CRS is in latitudes and longitude. So we've learned a new expression that allows us to extract coordinates into the WKT format, right? And then we've also learned how to convert the coordinates that we've gotten into latitude and longitude, or into any other coordinate system that you want. Okay, so now all we have to do is go to our PowerPoint, and this was the expression that we copy and pasted in our text area, right? So what do they do? So the geom WTK, what it stands for, geometry to well-known text. So it converts geometry objects, points, lines, polygons, multi-polygons into well-known text representation, which is the standard format for representing geometric shapes as text or strings, right? So usually you see them in this sort of format. So you have point if it's a point, polygon if it's a polygon, multi-polygon if it's a multi-polygon, and line if it's a line, so on and so forth. Okay, so then we have the transform. So what a transform does is that it sort of transforms the geometry from one coordinate reference system, as we talked about, to another coordinate reference system. So in our case, we are using EPSG 32630. It's a coordinate reference system that is a EPSG code for the WGS 84 UTM zone 30N, right? Zone 30M. So that's for places around Western Europe and parts of West Africa, which includes Ghana. So we converted from that particular coordinate system to a universal coordinate system, so a geographic or latitude and longitude coordinate reference system. So then you've been seeing there's the $sign geometry. So it's sort of it's a variable. It represents the geometry of the current feature or the current layer. So in our case, our current layer was Ghana, right? The Ghana layer, Ghana shapefile. So it sort of signifies or represents the geometry of the current layer. Okay, so I think that is it. We can give a summary of expression so far. So the expression, the provided expression, takes the geometry of the current feature, which represents by the $sign geometry, and transforms it from the UTM zone 30N coordinates system to a standard WGS 84 longitude system, and then converts this transform geometry into a readable text format using the well-known text standard. So that's just it for video. Thanks for sticking with me. And then in the last installment of this series, we will be dealing with the simplest way of getting the coordinates from your shapefile, right? And also there will be a bonus section of how to change the reference system part 1 expression. So yeah, see you in the next video.